All right, just a quick video here on the restrictions on the domains of functions. All right, so if you have a radical symbol and that root is even, in other words, the root is 2, 4, 6, etc. Okay, and remember the square root is root 2. So if you have a radical with an even root, that part of the function has to be greater than or equal to 0. And I'll show you an example in a moment. However, if you have a radical with an odd root, in other words, the root is 3 or 5 or 7, there are no restrictions, okay? And that's because you can take the odd root of a negative number. So let's look at a couple of examples real quick. All right, so real quick, for an even root, let's say you tried to take the square root of -4. There is no real solution here, okay? In order to solve this, you would have to do imaginary numbers. So this is no good for the domain of a square root. You can't have a negative. All right, however, for an odd root, let's say you tried to take the third root of -8. Well, the third root of -8 is the equivalent of -2 times -2 times -2. And the third root of that would just be -2. All right. So like I said, for the odd root, like say the root is 3, there are no restrictions. But for the even root, it has to be greater than or equal to 0. Otherwise, you will get no real solutions. Okay, and finally, let's say you have a rational function, something divided by something in the form of a fraction. In the numerator, there are no restrictions, okay? So long as you don't have a radical with an even root, okay, there are no restrictions in the numerator. However, in the denominator cannot equal 0, okay? And that, of course, is because you cannot divide by 0. All right, so for some examples, please see my video, Chapter 2.3, Intro to Functions, Domain and Range. All right, so see this video for some examples.